Hello everyone, welcome. Hello Sagar, hello Ayan Pasha, hello G-Sod, Mithun Gowda, Prajwal, Sweet Commander, hi. Hello, sorry for slight delay. I was occupied with something else, so that's why I was not able to start exactly at 5. So but anyway, we are not super delayed as well. Hello Jayashree. So now today we are starting with our PU2 PYQs. So I am going to discuss three very important chapters: electric charges and field, current electricity, and electrostatic potential and capacitance. Actually order is slightly wrong over here. Electric charges, electrostatic potential, and current electricity, these three chapters we will discuss all the important PYQs from this chapter. Obviously those who are preparing for KCET, they cannot miss this session because all the chapters are super duper important, right? So without any delay we will start with our class. So first question, this question came in 2025. A metallic sphere of radius r carrying a charge q is kept at a certain distance from another metallic sphere of radius r by 4, carrying a charge capital Q. What is the electric flux at any point inside the metallic sphere of radius capital R due to the sphere of radius r by 4? So let's see. Here we have a metallic sphere of radius r, metallic sphere of capital R, okay, and it has a charge of small q, okay, and another sphere of radius r by 4 has a charge capital Q. Okay, what is the electric flux at any point inside the metallic sphere of radius r due to the sphere of radius r by 4? So what is the flux inside this due to this sphere? Okay, so that is the question. We are trying to find the flux inside the this sphere due to this sphere. Okay, so what is the answer? Most of you are saying option 1 or option A, which is 0. Now any metallic sphere, if it is a metallic sphere, flux inside will always be 0. Does not matter whatever is the charge inside, whatever you consider because of the charge outside. It is a metallic sphere, so net charge anyway because of any charge situating outside, Gauss's law says that the electric flux will be 0, and metallic sphere anyway does not have any net flux inside it, so that means flux will be 0 inside. Okay, now let's move on to the next question. You are given a dipole of charge plus q and minus q separated by a distance 2r. So here we have a plus q charge, minus q charge separated by 2r distance. Okay, a sphere A of radius capital R, a sphere A of radius capital R passes through the center of the dipole as shown. So this is a dipole, okay, and another sphere B of radius 2r passes through the charge plus q, then the electric flux through the sphere A. Now here we have a dipole plus q minus q. Here we have a one sphere of radius r which is passing through the center. Now they are asking what is the flux of this sphere, what is the flux coming out of this sphere. Okay, now what about this one? Answer this. Akash Parig is saying C. Now good evening everyone. So year of PYQ is mentioned here. If you see, year of PYQ is mentioned in the question. Okay, some of you are asking, sir, year of PYQ. Year of PYQ is mentioned in the question itself. Okay, option C. Most of you are saying option C. What is option C? Option C is minus. So here even though it is a dipole, even though one of them is minus, one of them is plus, okay, because this sphere is containing only one charge, because this sphere contains only one charge, the electric flux coming out of this will be charge enclosed divided by epsilon naught. This is Gauss's law. Gauss's law states that the electric flux is phi equals to minus q by epsilon naught. So it will be minus q by epsilon naught because the charge inside here is minus. Just a second, give me just a second. Focus was slightly off. Now I think it's fine. So here remember that the flux enclosed does not matter whatever charge outside. Okay, outside the sphere charge is immaterial, so only inside the sphere charge is minus q, so total flux should be minus q by epsilon naught. If you consider the sphere B, then the charge enclosed will be zeros. In that case flux will be 0. Okay, yes, option C or option question number 3, option 3 is correct. Next question. Charges are uniformly spread on the surface of a conducting sphere. The electric field from the center of the sphere to a point outside the sphere varies with the distance r from the center s. So charges are uniformly spread across a sphere. Okay. Now here the sphere is conducting sphere. Conducting means metallic sphere. Okay, the electric field from the center of the sphere, so electric field from the center of the sphere till outside, how does it vary? Okay, very interesting question. Now let's see who can answer this question. Yes, I can already see some of the correct answer. I see Kirti's answered. Kirti, your answer is wrong. I will explain why your answer is wrong. Okay, remember that electric field inside a conductor will be 0. So if you start plotting the graph, what you will get, inside up to this point electric field will be 0. Okay, up to this point electric field will be 0. 0 means there is no line passing here, and from the surface it suddenly becomes maximum. From the surface it suddenly becomes maximum and then slowly goes to 0. Okay, as you are going out, so electric field is given by outside, it is k q by r square, right? So for r less than capital R, electric field is 0. Okay, suddenly just after the surface it goes to a maximum possible value, and then with the distance it slowly decreases. So correct answer is option 4. Correct answer is option 4, option D. Okay, so this is the correct answer, not this one, not this one. Okay, make sure this is correct, and this is not even correct for anything. Okay, this is like a gravitational acceleration graph. Okay, gravitational acceleration actually obeys this graph. Now, next, before I continue, just to remind you, KC30 is still available, but for a very limited time. If you still want to register for KC30 course, where you will not only get all the lectures of PU1, PU2 and their PYQs, you will also get live doubt classes where all the teachers including me will come and solve all of your doubt in the live class. Okay, so if you want all the support from us, definitely the price of the course is only 2499, so don't miss out on this. If you want to join, I think today or tomorrow the registration will be closed, so don't wait. If you are still thinking that I may need a support with my KCET preparation, definitely KC30 is one of the most loved after, one of the most sought after course, and we are still receiving requests from the students, sir, please keep on continue with the registration. So that's why it is still open, but in a day or two the registration will be closed, so don't wait if you still looking for support for your KCET preparation, right? 24 days are left. Now, which of the following is a correct statement? Gauss's law is not applicable when charges are not symmetrically distributed over a closed surface. Gauss's law does not hold good for a charge situated outside Gaussian surface. Gauss's law is true for any closed surface. Gauss's law is true for any open surface. Which of the following is a correct statement? You have to find the correct statement. Let's see who can answer. Okay, I see some of you have answered. Jisod, Anant, Sweet, Ilu Khan, Kirti. Yes, all of you have answered this correctly. Gauss's law is true for any closed surface. In one of the year, the question option was given Gauss's law is valid for any surface. So they have not mentioned this close. Remember, this is very important. You cannot ignore this term. If closed is not mentioned, Gauss's law is not valid. Okay, Gauss's law is applicable only for closed surface. It is not applicable to any surface. It is only for any closed surface it is applicable. It does not matter shape and size. It can be any shape and size as long as it is closed. Gauss's law is valid. Okay. Now let's move on to the question number 5. The total electric flux through a closed spherical surface of radius small r enclosing an electric dipole of dipole moment 2aq is given. Epsilon naught is the permittivity of free space. So this is there was a question in 2025. A similar question came in 2024 as well. Okay, so here the surface is a closed surface, and the closed surface has closing an electric dipole of dipole moment 2aq. It is completely is completely enclosed inside the surface. So what is the electric flux? What is the flux here? Okay, so if you see that Gauss's law is one of the most important concept of KCET, okay, 2025, 2024 and counting 2026 also. I hope there will be questions from Gauss's law. Okay, this is one of the most sought out. In fact, in 2025, out of the 4 questions came directly, 3 of them are from Gauss's law. Okay, so here the electric flux will be 0. Why? Because both positive and negative, both charges are included inside the sphere. Okay, it's mentioned that total flux through a closed spherical surface of radius are enclosing a dipole. So enclosing means entire dipole is closed inside this surface. That means the total charge enclosed is 0. Total charge enclosed is 0 means the flux will be also 0. Now next question. A uniform electric field E equals 3 into 10 to the power of 5 Newton per coulomb is acting along the positive y axis. The electric flux through a rectangle of area 10 centimeter into 30 centimeter whose plane is parallel to zx plane is. So let us draw the diagram. So first of all, suppose this is my x-axis, this is my y-axis, and z-axis is like this out of this plane. Okay, this is my z-axis. Now it says that electric field is along positive y-axis. This is the direction of electric field. Now any surface parallel to xz plane will be like this. Any surface which is parallel to xz plane will be like this. So basically this electric field is normal to the surface. The electric field is normal to the surface. Now what is the length? Length is 10 centimeter and breadth is 30 centimeter. Okay, so of this surface it is 10 by 30, that is given in the question. So what is the electric flux? So first question where actually we need to do some calculation. Okay, this is first question where we actually need to do some calculation. So electric field is given by electric flux is given by E into A cos theta. Now here the surface, the direction of surface A is normal to the surface, and surface is or area vector, right? Area vector and electric field both are in the same direction. If two vectors are in the same direction, then angle between them will be 0. If angle is 0, then cos theta will be 1. So in this case the electric flux is simply E into A. Now here you have to remember that area is given in centimeters, so only mistake that student will make is they will not convert this centimeter into meter. So that is the only mistake, otherwise this is a very simple problem. So electric field is 3 into 10 to the power of 5, area is 10 into 30, but 10 means 10 into 10 to the power of minus 2 and 30 means 30 into 10 to the power of minus 2. So you have to consider all the zeros. So it will be 3 3s are 9 and 1 0 less, 2 0 less. So these zeros are gone. Now 10 to the power of minus 2, 10 to the power of 5. So 9 into 10 to the power of 3 voltmeter is the answer. Okay, so it will be 9 into 10 to the power of 3 voltmeter. Even if you make mistake in the unit, if you see the options, yeah, you will be very sure that 3 into 3 is 9. So only 9 could be the correct answer. Okay, so 9 into 10 to the power of 3 is the correct answer for this question. So option B is correct. Yes, option B. Most of you have answered. Sweet, I am, draws, okay, Akshata, G-Sod, Anant, Kavana, Kavya. So most of you have answered this correct. Now next question. A body has a charge of minus 3.2 microcoulomb. The number of excess electron it has. Now this problem can be solved in two ways. I will teach you, because it is given in the form of 3.2, it is easier. But if it is given in any other value, how to treat that, how to solve that, that also I will teach you, don't worry. So first of all, what is the question? Charge is given and we are trying to find number of electrons. So N into E is the charge, right, which is 3.2. My sign of the charge does not matter, because sign means basically extra electron or less electron. Okay, if it is positive, then less electron. If it is negative, means excess electron. Okay, that's it. Now, so number of electron will be given by 3.2 into 10 to the power of minus 6 divided by charge of an electron, that is 1.6 into 10 to the power of minus 19. So you can simply cancel that 2. So you will get 2 into 10 to the power of 13 extra electron. 2 into 10 to the power of 13 extra electron. So correct answer is option C. Now I told you I will teach you a shortcut method. Suppose instead of giving this as 3.2, suppose 2 microcoulomb is given, or say 5 microcoulomb is given, or 1 microcoulomb is given, okay, or 1 nanocoulomb is given, then how to convert? Okay, so if it is a multiplier of 1.6, then use this formula. Very simple. Okay, 1.6, 3.2, 4.8, 6.4. If those values are given, use this formula. This is faster. But any whole number is given. If it is a whole number, then remember that 1 coulomb of charge equals to 6.25 into 10 to the power of 18 number of electron. If you remember this conversion factor, any other charge can be simplified. For example, 2 microcoulomb. 2 microcoulomb means 2 into 10 to the power of minus 6 coulomb. Now we know 1 coulomb is this, so it will be 2 into 6.25 into 10 to the power of 18 minus 6. Very simple. So that will be 12.5 into 10 to the power of 12. So if any other charges are given, then you should use this conversion factor. Okay, 6.25 into 10 to the power of 18, that is 1 coulomb charge. Okay, but in case you just get an answer where you just need to the value is multiplier of 1.6, you can use this formula. That is also super easy. Now let's move on to the next question, question number 8. A point charge A of plus 10 microcoulomb and another point charge B of plus 20 microcoulomb are kept 1 meter apart in free space. The electrostatic force on A due to B is F1 and electrostatic force on B due to A is F2, then which of the relationship is correct? Again, another easy question, no need to do any mathematics. So all the questions from this chapter, as you can see so far, are very easy. There was once or twice some difficult questions came, but remember that if the question is difficult, it is difficult for everyone, not only for you, it is difficult for everyone. Okay, and instead of wasting time on a very difficult question, so 10 minutes, 15 minutes wasting time on a single question, you should just read it. If you feel that, okay, I know the formulas, I should try to solve it, solve it. If you don't feel that, okay, I will not be able to solve it, it is a very lengthy question, or maybe the formulas I don't know, skip those questions. Okay, you will nobody is asking you to, you have to score 60 out of 60. Okay, you can guess that answer and move on to the next question. Okay, there was one instant where there is a very difficult question came from this chapter. Okay, and if you try to solve that question, it would take minimum 10 minutes of time. So 10 minutes of time you could have answered 10 another question. Instead you wasted on that single question, and your exam actually will be ruined. Okay, so don't do that. If the question is easy, obviously this kind of questions where it's basically Newton's third law of motion, two charges are there. Okay, if force on this is F1, force on this is F2, they has to be equal and opposite. They has to be equal and opposite. That is the Newton's third law, right? Action and reaction. Electric field at a distance small r from an infinitely long uniformly charged straight conductor having linear charge density lambda is E1. Another uniformly charged conductor having same linear charge density lambda is bent into a semicircle of radius r. The electric field at its center is E2. Then what is the relationship between E1 and E2? So first we have a long wire, electric field charge is density is lambda. Okay, now you have another wire, you bent it into a semicircle, and you are trying to find electric field at its center. Now again, this is a difficult problem if you try to solve it mathematically. This will be a very difficult problem. Okay, if you want to do the integration, how to solve it, you need to take a small element here, solve it. Okay, take the integration, then add all the electric field, and then you will get the net electric field. Okay, net electric field. But there is a easier way is to understand that, because we are considering a long wire. Okay, the electric field is generally given by E is equal to 1 by 2 pi epsilon naught lambda by r, and if you calculate the electric field for this also, you will get the same value. So E1 and E2 will be equal. Okay, mathematically if you try to solve this question, it is a very long question, another 10 minutes will be gone. You will guess the answer, move on. Guess the answer, move on. If you see the question is difficult, it will take some time for you to solve. Okay, so this is how you should attempt such questions. Even though the question seems easy, it is actually not very easy question. Okay, it is not actually very easy question, as I mentioned. Okay, you have to take the small things, then integrate it from 0 to pi by 2, so that will take very long time. Now let's move on to the next question. A cubical Gaussian surface has a side of length A equals to 10 centimeter. Electric field lines are parallel to x-axis as shown. So here electric field lines are parallel to x-axis as shown. Okay, the magnitudes of electric field through surface A, B, C, D. So magnitude of electric field through the surface A, B, C, D. So this one is A, B, C, D. This one is the A, B, C, D surface. Okay, the field is 6 kilonewton. So here 6 kilonewton per coulomb, and through the surface EFGH, so through this surface it is 9 kilonewton per coulomb. Okay, so electric fields are given. Okay, respectively, the total charge enclosed by the cube. Total charge enclosed by the cube. Suppose the total charge enclosed is Q. Okay, so obviously we know that from Gauss's law, the flux is given by charge enclosed by epsilon naught. Okay, value of epsilon naught is given 9 into 10 to the power of minus 12. You have to calculate the charge enclosed. For that, you have to find the net flux. You have to calculate the net flux. How to calculate the net flux? Net flux is obviously total outgoing flux. Net flux is total outgoing flux. So if you see that here 6 kilonewton is coming in and 9 kilonewton is going out. Okay, 6 kilonewton per coulomb is coming in and 9 kilonewton per coulomb is going out. So what is the net inside electric field? Net inside electric field is 9 minus 6, but it is given in kilonewton, so you have to multiply with 10 to the power of 3. Kilonewton means multiply by 10 to the power of 3. So this is the electric field portion into area. What is area here? If you see, all the sides are 10 centimeter, all the sides are given here 10 centimeter. So it's a square. So square's area is 10 into 10, but again, don't make mistake, it is a centimeter, so you have to convert it into 10 to the power of minus 2 into 10 into 10 to the power of minus 2. You have to convert it into meter. Now 10 into 10 is 10 square, that is 100. So this one will cancel each other out. Okay, 10 into 10 is 100. 100 divided by 100 is 1. So this one will cancel each other out. So what we are left with? We are left with this. So it will be so this will be 3 into 10 to the power of 10 to the power of plus 1, that is 30. Now here remember, this is not the answer. Here we have only calculated the flux. Now we have to put that over here and calculate the enclosed, charge enclosed. Charge enclosed is phi into epsilon naught. So phi is 30, epsilon naught is 9 into 10 to the power of minus 12. So it will be 270 into 10 to the power of minus 12, or 0.27 into 10 to the power of minus 9, that is 0.27 nanocoulomb. 0.27 nanocoulomb. Charge is positive here. Why charge is positive? Because if you see net incoming flux and net outgoing flux, between them outgoing flux is more. So outgoing flux is more means obviously the charge inside is positive. That's why it is giving a net outgoing flux. Okay, if the charge is negative, then incoming flux would be more, outgoing flux will be less. So remember this is a very interesting important concept. If the incoming flux is more, then the charge is negative. If outgoing flux is more, then charge is positive. Because for a positive charge, if you remember positive charge, the field lines goes out, the net field lines goes out. Okay, for a negative charge, field lines comes in. So net flux is positive for a positive charge, net flux is negative for a negative charge. So it will be plus 0.27. Yes, I can see most of you, Akshata, Sweet, Jayashri, Kavya, Sandeep, Anant, so most of you have answered correctly. Now let's move on to the next question. Under electrostatic condition of a charged conductor, which among the following statement is true? The electric field on the surface of a charged conductor is sigma by 2 epsilon naught. So you have to find true. One of them is true, remaining are false. The electric field on the surface of a charged conductor is sigma by 2 epsilon naught, where sigma is the surface charge density. The electric potential inside a charged conductor is always 0. Any excess charge resides on the surface of the conductor. Net electric field is tangential to the surface of the conductor. So we will verify one by one. So the electric field near the charge of a near the surface of a conductor is given by sigma by epsilon naught. Okay, sigma by 2 epsilon naught is a charged infinite sheet. Charged infinite sheet, if you take an infinite sheet, then it becomes sigma by 2 epsilon naught. That is not a conducting sheet. But for a conductor, the sheet need not to be a infinite, but as long as the point is very close to the charged conductor, it is given by sigma by epsilon naught. So these two are very common mistake that students makes. So this is incorrect statement. The electric potential inside a charged conductor is constant. Electric field is 0. So potential 0 is not correct. Potential 0 is not correct. Electric field is 0. Potential is constant. Any excess charge resides on the surface of the conductor. This statement is correct. Okay, whatever charge you give it to a conductor, charge will always stay on the surface. It will not go inside the surface. Okay, this is also an application of this is electrostatic shielding. Net electric field is not tangential. Net electric field on a charged conductor is always normal. Okay, it is always normal. It is not tangential. Tangential means if the electric field is in this direction, then it is called tangential. But electric field is not tangential. It is normal. It is normal. Okay, so obviously this statement is also wrong. So only correct statement among this is again option C. Okay, Akshata, Sumant, Jayashree, Sweet, most of you have answered correctly. Now let's move on to question number 12. A uniform electric field vector E exists along the horizontal direction as shown in the figure. The electric potential at A is VA. A small point charge Q is slowly taken from A to B along the curved path as shown in the figure. Okay, the potential energy of the charge when it is at point B is, so charge is taken from A to B and the potential of A is given, potential at A is given. Okay, potential at A is given as VA. Okay, potential at A is given VA. Okay, the distance is given x, the constant electric field is given as E. Constant electric field is given, potential at A is given and the distance is given. Now they ask you what is the energy at this point B. Now what is the energy of a charge in an electric field? If you can somehow find the potential at this point, if you can somehow find the potential at this point, we know that the energy of a charge is actually charge into the potential at that point. Charge into potential is the electric potential energy of a charge. Now here obviously QB is not given. So how to find QB? For that we will be using electric field is given by minus dV by dx. Okay, electric field is given by minus dV by dx. So E equals to minus final potential minus initial potential divided by the distance between them. dV is difference in potential, VB minus VA, and that is equals to x, or it will be minus VB plus VA by x, right? If you multiply the negative sign, or EX equals to minus VB plus VA, or VB equals to VA minus EX. Okay, this goes here, becomes positive, this goes on the right hand side, becomes negative. So VB equals to VA minus EX. Next, what you have to find, use the potential energy formula. So potential energy is Q into VA minus EX. Now obviously electrostatic field is a conservative field. It does not matter you take this path or any other path or the straight line path, this potential energy will always be same. Okay, so it will be VA minus EX. Okay, if you have confusion, always go back to the fundamental equation, and obviously the negative sign is very important over here as well. Okay, so I can see, hi Prajwal, most of you have answered this question correctly. Most of you have answered this question correctly. Sweet, Anant, Sumant, Jayashree, Sandeep came later, but by the time Sandeep answered, I solved this question. Now let's see the next question. A parallel plate capacitor of capacitance C1 with a dielectric slab in between its plate is connected to a battery. Okay, it has potential difference V1 across its plates. When the dielectric is removed, potential difference are C2 and V2 respectively. So parallel plate capacitor, okay, having a dielectric plate inserted between the plates, dielectric slab between the plates, capacitance is C1. Okay, so it is connected to a battery of potential V1. Okay, when the dielectric is removed, now what you have done, you have removed the dielectric. You have removed the dielectric. Now again, it is not mentioned that whether the battery is disconnected or not. So that means we can assume that the battery is still connected. Only thing that you have done, you have removed the dielectric slab. Okay, so potential difference should remain same. So if you remove the dielectric slab, because the source potential is same, so V1 must be equals to V2. Now if you see that there are two options where V1 is equals to V2. Now we have to understand which one will have a higher capacitance. Which one will have a higher capacitance? Our capacitance with dielectric is more than capacitance without dielectric. That is why we use dielectric, right? So capacitance with dielectric is more compared to capacitance without dielectric. That means C1 must be greater than C2. C1 must be greater than C2. I think one small error is there, so let me say the second one is 2. Okay, second one is 2, so obviously we can see that C1 is greater than C2, so option C is correct. Okay, option C is correct. Okay, again I can see Anant, Tarun, Kavna, Sweet, Jayashree, all of you have answered correctly. Now let's move on to the question number 14. The electric field and potential of an electric dipole along its axis vary with distance r respectively as. So electric field and potential of a dipole. So electric field due to a dipole is proportional to 1 upon r cube. Does not matter whether it is along the axial, along the equatorial or any other arbitrary direction. Electric field for a dipole varies with 1 upon r cube. And electric potential due to a dipole, both of them are for dipole. Okay, and electric potential due to a dipole varies as 1 upon r square. So this is actually quite contradictory for a single charge. For a single charge, electric field varies as 1 upon r square and potential varies as 1 upon r. But for a dipole has two charges, so power of r increases. Okay, so it will be r cube and r square. So it will be 1 upon r cube and 1 upon r square. Now remember, all such questions you make sure you understand the order. Okay, so first is electric field, second is potential, then 1 upon r cube and 1 upon r square. Suppose the same question is asked to you. First they ask that potential and electric field. So if they change the order, your answer will be changed. Okay, your answer will be changed to this one. So make sure you whenever you are answering order based or ratio based questions, you make sure whatever is the order given in the question, your answer also follows the same order. Otherwise you will do the hard work, you will solve it, but you will do the opposite of what you are supposed to write. Okay, so that is the main trick in case of ratio based questions. Okay, now next, two tiny spheres carrying charges 1.8 microcoulomb and 2.8 microcoulomb are located at 40 centimeter apart. The potential at the midpoint of the line joining the two charges. So here we have two charges. One of them is 1.8 microcoulomb, one another is 2.8 microcoulomb. So we are trying to find electric potential, not electric field, electric potential at the midpoint. Okay, so they are 40 centimeter apart, so total distance is 40. That means this is 20 and this is also 20. Okay, so these two distances must be 20. Now what is electric potential due to a charge? Electric potential due to a charge is given by K Q1 by R. Okay, now because both distances are same, and electric potential gets added algebraically, because this is a scalar quantity, we can write the net potential. This is a shortcut, that is K upon R into Q1 plus Q2. This is only valid when the distance is same. If both are at different distances, you will not be able to use this formula. Okay, because distance is same, we will not write individually, we will not calculate the potentials individually and solve it. We will write the formula directly, and then we will say, okay, because the distance is same, we can simply add the charges. Now 9 into 10 to the power of 9 divided by 20 into 10 to the power of minus 2, because it's a centimeter, you have to convert it into meter. Now Q1 plus Q2 means 1.8 plus 2.8, which is 4.6. Okay, it will be 4.6. So 4.6 microcoulomb, that means 10 to the power of minus 6. Okay, so let us first calculate as much as possible. So it will be 10 and it will be 2.3. 2.3 means 2.3 into 9. So 2 into 9 is 18. Okay, 2 into 9 is 18 and 3 into 9 is 27. There is a decimal, so it will be 20.7. It will be 20.7. So 20.7. Now let us calculate the 10 to the power value. So here we get 10 and 10 to the power of minus 2. So eventually we get 10 to the power of plus 1, 10 and minus 2. So that is minus 1. It is in division, it goes up, becomes positive, and here we have minus 6 from this. Okay, so 20.7 into 10 to the power of 10 minus 6, 4. Okay, 20.7 into 10 to the power of 4. If you see the option, none of the answer is actually matching with this direct calculation, but if you even simplify it little bit more, if you take one more decimal out, okay, then you get 2.07 into 10 to the power of 5. Right, if you take decimal one more inside, then 1 0 increases, so that will be 10 to the power of 5. So now our answer matches with option D, that is 2.1 into 10 to the power of 5 volt. Okay, okay, sir, you explain once more. So the explanation is, so if you want to calculate, suppose here we have a charge Q1, here we have a charge Q2, okay, and they ask you, okay, the distance between them is so and so, what is the electric potential at the midpoint? So electric potential at the midpoint means, if this distance is R, this distance will also be R. Okay, so what is the electric potential at the midpoint due to this charge? That will be V1 equals to K Q1 upon R1. Right? What will be the electric potential here due to the second charge? It will be V2 equals to K Q2 by R2. Now R and R1 and R2 both are same. R1 and R2 are both are same. Okay, R1 and R2 are same. So both of them will be same R. Okay, both of them will have same R. Now what is the total potential? Total potential is a scalar quantity. Scalar quantity means 2 plus 2 is 4. If it is a vector quantity, 2 plus 2 may not be equals to 4. Vector quantity, you have to consider the direction as well. 2 plus 2 can maximum be 4, minimum be 0. Okay, 2 plus 2 in vector quantities lies between 0 to 4. Okay, but for scalar quantity, 2 plus 2 is simply 4. Okay, so here what is the total potential? Total potential is just addition, algebraic addition. So now if you add these two quantities, K by R is common. K by R is common, so you can get Q1 plus Q2. So this formula is valid when they ask you if the distance is same, if they ask you at the midpoint. So these kind of cases, this is a shortcut formula that you might use that will save some time for you. Okay, this calculation you don't need to do it. You don't need to do this calculation. You just need to start with here. That will actually give you a head start, because eventually the multiplication calculations, everything will be simplified. So once you do that, now put the value of K value known, R value is half of 40, because midpoint means half of 40, half of 40 is 20, so 20 centimeter. Now main thing here is calculating the 10 to the power of values. Okay, so be careful while calculating 10 to the power values. 20 centimeter has to be converted into meter, and correspondingly you have to calculate the 10 to the power of value. Okay, so after we calculating, we got 20.7, but 20.7 is not there. Okay, only 1 2 is there with 10 to the power of 5. We got 10 to the power of 4, but 20.7 we can move one decimal towards our left and increase the 10 to the power of value by 1, right? 20 into 10 to the power of 4 means 2 into 10 to the power of 5, right? 1 0 is basically shifted. So that's why we have written it like that. Now if you take this the closest one decimal, if you try to find it up to one decimal point only, then it becomes 2.1 into 10 to the power of 5. Okay, so if you round off to one decimal only, then it becomes 2.1. So this is the answer. Okay, clear? Now let's move on to the next question. A parallel plate capacitor is charged by connecting a 2-volt battery across it. Okay, then disconnected from the battery and a glass slab is introduced between the plates. Which of the following quantities decrease? So here we have a capacitor. Okay, it is charged to 2-volt potential. You charge it to 2-volt potential, and then what you have done, you have inserted a glass slab. Glass slab means what? Glass is a dielectric medium. So basically what you have done, you have inserted a dielectric medium between the plates. So initially capacitor was charged at 2 volt. Okay, suppose the initial capacitance was C1. Okay, final capacitance is C2. V1 is 2 volt. What is V2? And what are all the quantities that changes? Okay, energy stored. Now they ask you which quantity decrease. Okay, some of them will increase, some of them will decrease. Energy stored, capacitance, charge, potential difference, capacitance and charge, potential difference and energy stored. Which of the quantity will decrease? Answer this question quickly. Let me have some water in between. So which of the following quantities decrease? Some are saying D, some are saying A. So remember that capacitance, if you add a dielectric medium, capacitance always increases. Capacitance is given by K A epsilon naught by D. Generally we do not use this K because for air K is 1. Okay, but for any other medium, if it's glass, it's mica or any other medium, K is not 1. K's value is more than 1. Okay, for air it is minimum, which is 1. For any other medium, K is always greater than 1. Okay, for vacuum and air, K is equals to 1. For any other medium, K value is always greater than 1. K value cannot be less than 1. So if you add a dielectric medium, capacitance always increases. So capacitance increases. So that means options which have capacitance in it actually wrong. Now what about charge? Charge is a conserved quantity. So if you once you have charged the capacitor, disconnected it from the battery, and you have inserted the glass slab. Charge, it is an isolated system. Even though you are adding a glass slab is neutral. Okay, it does not have any charge in it to begin with. That means the system will be neutral. System will still have the same charge that is it had before. That means charge will remain constant. So charge again will not include any of the options. So if you eliminate this way, you will see that potential difference and energy stored are actually decreasing. Okay, if you remember that if you add a dielectric slab, capacitance increases. Capacitance increases means that the voltage across between the plates has to decrease. Okay, because the capacitance increase means now it can store more charge. So more charge means it is now hungry. So its potential decreases. Now it wants to eat more food. Potential is like a food to a capacitor. Okay, so that means its potential decreases. It has now a very hungry. It wants to eat a lot of food. So that means what happens is that its potential decreases. Energy stored, again as I mentioned, energy stored decreases because now it wants to consume more energy. It wants to eat more, it wants to gain energy, but now at this present energy actually decreased. Okay, V decreasing means energy decreased. Okay, now next question. If a slab of insulating material of 4 into 10 to the power of minus 3 meter thick is introduced between the plates of a parallel plate capacitor, separation between the plates has to be increased by 3.5 into 10 to the power of minus 3 meter to restore the capacitance, restore the capacity to the original value. The dielectric constant of the material will be. So solve this quickly and tell me the answer. Let me calculate that as well. 3.5. Sir, how many questions will you take? I will take 30 questions, not 20 today. We will be solving 30 questions in today's session. Yes, yes. So here the increase in gap is given by D equals to T into 1 minus 1 by K, I think. Minus 1 by K, if I remember this correctly. Minus or plus? Okay, let's see. So the dielectric, the distance by which it is increased, which is this, and the thickness of the dielectric medium is this. Okay, so let's see. So this has to be the increase in thickness to adjust the dielectric constant. This is the shortcut formula that you can use. So this is 3.5, this is 4, obviously 10 to the power of minus 3 cancels, and we get 1 minus 1 by K. So you get 3.5 by 4 equals to 1 minus 1 by K, or 1 by K is equals to 1 minus 3.5 by 4, which is 4 minus 3.5 by 4. So that is K equals to 4 by 0.5. Yes, this is correct. So this is 8. Okay, I remember the answer, but I forgot this formula. Okay, so remember, if you have a capacitor, suppose you inserted a dielectric medium of thickness T. Okay, now to balance the capacitance, what you have done, you have increased the air gap such that the air gap is now D. Okay, so you inserted a dielectric medium which will actually increase the capacitance. Now you want to decrease the capacitance. To decrease the capacitance, you have extended the air gap inside the capacitor plate. Then if the dielectric constant is given by K, then how can you find this distance? To find this distance, you have to use D is equal to thickness T of the dielectric slab, okay, into 1 minus 1 by K. This is a formula. This can be derived using theory, but again we do not have the time to solve using theory in the exam. So if you remember this formula, that will save you a lot of time. Now for JEE student, this is a very common formula. Okay, many of the JEE student have used this formula, but for KCET student may not be super familiar. But remember that this question came only once in 2021. So if you remember it, it will be very helpful. It will save you some time. Okay, any question? Yes, minus only. Yes, thank you Prajwal. Now 8 drops of mercury of equal radii combine to form a big drop. The capacitance of a bigger drop as compared to each smaller drop is. So here 8 drops of mercury of equal radii. 8 drops of mercury of equal radii. So here we have 8 such drops. Okay, they combine to form one bigger drop, say radius capital R. Okay, the capacitance of bigger drop as compared to smaller drop is. Now for a spherical conductor or spherical conducting surface, the capacitance is directly proportional to its radius. Okay, for a spherical capacitor, capacitance is directly proportional to its radius. So initially the capacitance is proportional to R. Now what is the final capacitance? Final capacitance must be proportional to capital R. Now if you know how to find the capital R, that will save you a lot of time. Okay, if you this is not only this question, there are many other questions where they might say that charges are combined together. What is the electric field? What is electric potential? Water droplets combined together, what is the viscosity? So all those chapters you might face this. Remember that when few spherical drops combine, okay, the radius of the bigger sphere is equals to n to the power of 1/3 into radius of the smaller sphere. Okay, remember that. You can find the volume, add them, and you can calculate it, but this is the formula that is very common across many different style of question. Not only here, it will be helpful in many other question. I have solved one question in Q1 as well. Okay, so radius of the sphere is given by n to the power of 1/3 into r. What is n? N is number of the smaller sphere. So what is the number here? Number of smaller sphere was 8. So 8 to the power of 1/3 into r, that is 2 into r. So radius is getting doubled, so capacitance will be doubled as well. So capacitance will be 2 times, not 8 times, not 4 times, not 16 times. It will only be 2 times. Okay, capacitance of a spherical capacitor is proportional to radius. Now next question. An electrician requires a capacitance of 6 microfarad in a circuit across potential difference of 1.5 kilovolt. A large number of 2 microfarad capacitors which can withstand a potential difference of not more than 500 volt are available. The minimum number of capacitors required for the purposes. Now this is a design problem. If you read this question, if you understand it, similar question, suppose a design problem came in exam, okay, not exactly related to this concept, some other concept. If you understand it, okay, how to solve it, if you know, try it, otherwise you can skip that. This will, if you know it, if you know the concept in between this, then it will not take more than 2 to 3 minutes. But if you don't know it, if you try to find it in the exam hall, it can take up to 10 minutes as well. Okay, so here we have 6 microfarad capacitance. We are trying to build a capacitor having a capacitance of 6 microfarad, but we do not have this 6 microfarad capacitor. What we have is capacitor of 2 microfarad. Okay, capacitor of 2 microfarad. So you might say, sir, very easy. We will take 3 2 microfarad, connect them in parallel, and then we will get 6 microfarad. Parallel combination of capacitance gets added, but that will be wrong. Why? Because our power rating is, or the voltage rating of the capacitor must be 1.5 kilovolt. 1.5 kilovolt. Here we can only have if you connect these capacitors in parallel, it can withstand only 500 volt. Okay, 500 volt. 1.5 kilovolt means what? 1500 volt. Okay, it will burn. This capacitor, if you try to use, it will burn. Even though you will get 6 microfarad, but voltage rating will be different, so capacitor will not work. So how to solve such design problem? This kind of design problem is solved by drawing. Okay, first let us understand. First we will solve the voltage problem. How to do that? 3 capacitors, when we connect them in series, okay, the capacitors does not get added. Capacitance get added reciprocally, like the formula that we know. Okay, but the voltages gets added. Okay, voltages gets added. Kirchhoff's voltage law. So voltages gets added. So when you connect 3 capacitors of 500 volt each, okay, the voltages gets added. Now this capacitor can withstand 1500 volt. This capacitor can withstand 1500 volts. So our effective capacitance is here 2 microfarad, 2 microfarad, 2 microfarad. 3 of them are 2. So the equivalent capacitance of one line is 2 by 3. Okay. If capacitance in series, all of them are same, the equivalent capacitance will be 1 capacitor divided by 3. Okay. Now we need to use this combination. We need to use this combination one by one, and we need to find that how many such rows are required to make this a 6 microfarad capacitor. Okay, so our target is still 6 microfarad. Voltage is now solved. Obviously, now suppose we have 1 row, 2 row, 3 row. Suppose we have n such row, so that the total capacitance is now 6 microfarad. Each row has a capacitance of 2 by 3. Each row has 2 by 3, so n row will have n into 2 by 3. N into 2 by 3. So, and the final result is 6 microfarad. So, from here we can solve and we can say that n is equals to 6 into 3 divided by 2, which is equals to 9. So, how many rows we need? We need 9 such rows. Okay, each row has how many capacitors? 1, 2, 3. Okay, so total number of capacitors must be 9 into 3, that is 27. It is not 3 capacitors, not 5, not 6. Okay, it will be 27 capacitors. Very interesting design problem. Similar question came in Comet K exam as well. Comet K, even they tried to make this question even more complicated by adding eel. Okay, those who have solved Comet K papers know there are eels. Eels means fish. Okay, they are a type of fish. They generate electricity. Okay, so they instead of cells or capacitors, they give eels. Okay, so yes, it's a tricky question. So 1 by C1 plus 1 by C2 plus 1 by C3 is okay, but if the capacitors are same, no, you don't need to do 1 by C1 plus 1 by C2 plus 1 by C3. Okay, because what happens, it will be 1 by C equivalent equals to 1 by C plus 1 by C plus 1 by C. Okay, so it will be 3 by C, so C equivalent will be C by 3. Okay, so if equal value capacitors are connected in series, okay, equivalent capacitance is C divided by N. If C such capacitors are connected in parallel, equivalent capacitance is N into C. So these are the mathematical shortcut or formula wise shortcut that you need to know. Okay, now next question. In figure, charge on the capacitor is plotted against the potential difference across the capacitor. Okay, so here we have given charge on the capacitor is plotted against the potential difference across the capacitor. The capacitance and energy stored in the capacitor are respectively. We have to first find the energy stored, secondly you have to find the capacitor. Okay, we know that Q equals to C into V. So C equals to Q upon V. Now if you see this point here, you know the charge, you know the voltage as well. So what is charge? Charge is 120 microcoulomb. So 120 microcoulomb means 120 into 10 to the power of minus 6. Voltage is 10 volt. So 10 volt. So 0 0 cancel, so you get 12 microfarad. So capacitance is calculated. Now what is the energy stored? Will you use half CV square? That will be complicated later. Let's use one more formula, that is half Q square Q into V, sorry, half Q into V. Q is known, V is known, multiply them. Okay, so half 120 into 10 to the power of minus 6 into 10. Okay, so 2 is 60, 1 2 zeros. Okay, 6 into 10 to the power of minus 4. Okay, 6 into 10 to the power of minus 4, or you can say that it is 600 microjoules. 600 microjoules. So 12 microfarad, 600 microjoules. So obviously correct combination is B. Very easy question. Only you need to figure out at this point voltage and charge both is given. So you can use the formulas to calculate. Yes, most of you have answered correctly. Okay. Good evening, Stravya. Okay, question number 21. In the following circuit, the terminal voltage across the cell. So we have, so as you can see, electric charges, easy questions. Okay, except one question in 2018 or 2019 it came. Okay, other than that, most questions are actually easy. Electric potential, it is a mixture of easy and difficult. Now, current electricity. Current electricity, again, it is a mixture of easy and difficult. Some questions straightforward, direct questions, some questions you need to solve it. For example, this question. So they have asked you what is the terminal voltage across this. Terminal voltage across this means how to find terminal voltage. The method is very simple. You calculate the current. Okay, you calculate the current. Either you multiply with the resistance or you minus from this. Either you use this formula or you multiply V is equal to IR. Any one of the formula is correct. Okay, both formulas you can use. So we will be using the second formula. Let's see what is the current. How to find the current? To find current, basically the EMF of the cell divided by total resistance. Okay, EMF is given here 2 volt. External resistance is 3.9. Internal resistance is 0.1. So 2 by 4, that is 0.5 or half. So what is the voltage? Voltage is current. Current is half. Okay, let me not use 0.5, let me use half into the external resistance, which is 3.9. Okay, so it will be 1.95. Okay, 1.95. So correct answer is option A. Now if you want to use the second formula, sir, I want to use the second formula. Well, you can use that as well. So 0.1 is internal resistance, the current is 0.5. So 2 minus 0.05, 1.95. You will get the same answer. Okay, does not matter which formula you use, you will get the same answer always. Both formulas are okay. Two cells of EMF E1 and E2 are and internal resistances R1 and R2. Here it is mentioned E2 is greater than E1 and R2 is greater than R1 respectively, are connected in parallel as shown in the figure. The equivalent combination of E equivalent, then which relation is correct? E equivalent is greater than E2, E equivalent is less than E1, E equivalent is less than E equivalent and less than E2. So it is basically between these two values, and E equivalent is nearer to E1. E, again same relation, E equivalent is nearer to E2. So obviously we can guess that one of these two should be the correct answer. When two cells are in parallel, the equivalent EMF should be between these two. Okay, it cannot be more than that. Okay, it cannot be less than that as well. If in the extreme case, if both of them have same value, if both of them have same resistances, it is actually equal. Equivalent EMF is exactly equal to this value. Now how to solve this question is completely absurd. Okay, even if you understand, either you know the answer or you don't know the answer. So how to solve this kind of question? So remember that one very important thing, if the formula, if there is a concept which requires a formula but the values are not given, you can take your own values. This is very interesting to remember. If for example, parallel combination of cells, there is a formula, we know the formula, but values are not given here. So how to use the formula? You take your own values as you suit applicable. For example, I will take E1 is 1, R1 is 1. Okay, I will take E2 as 2, R2 as 2. Ohm and volt, obviously units are not same. Okay, now you might say, sir, can we take that? see if the condition is satisfied, E2 is greater than E1, E2 is greater than E1, R2 is greater than R1, R2 is greater than R1. So my both conditions are satisfied. So as long as both conditions satisfied, does not matter. So this must be a satisfaction of the formula. So we will use these values and calculate equivalent EMF. What is equivalent EMF? Equivalent EMF is, now I don't know which formula you use. I like to use this formula, E1 by R1 by E2 by R2 divided by 1 by R1 plus 1 by R2. This is the very easy formula to remember. Okay, now put all the values that we imagined, 1 by 1 plus 2 by 2 divided by 1 by 1 plus 1 by 2. Okay, so obviously in the numerator we get 1 plus 1, in the denominator we get 3 by 2. 1 plus half is 3 by 2, so it will be 2 by 3 by 2, that is 4 by 3. What is the value of 4 by 3? 4 by 3 is 1.33. The value is 1.33. Now what is the difference between 1 and 1.33? Difference between 1.33 and 1 is 0.33. Okay, now what is the difference between 2 and 1.33? 2 minus 1.33, which is 0.67. Now which one is closer? Which one is closer? So that means it is between these two values, and E equivalent is closer to E1. E equivalent is nearer to E1. Okay, so you just solve it taking your imaginary values. Okay, you can take any other value as you want. I have taken the simplest, easiest possible values, which saves some time. Okay, and after doing it we realize that the equivalent EMF is closer to smaller EMF. Equivalent EMF is closer to smaller EMF. Okay, so this is only the case where both are in the order. If they reverse the order, then it might give you a different result. Okay, but here in this case where E2 is greater than E1, R2 is greater than R1, then you will get that the equivalent EMF is closer to the smaller EMF. This is how you should approach a problem if values are not given. Okay, now let's move on to the next question. This is an easy question. The variation of resistivity rho with absolute temperature T for 3 different materials X, Y and Z are shown in the graph below. Identify the materials X, Y and Z. So obviously we have to identify the materials. Easy question. What is this? Here with the temperature resistivity increases, so this must be a resistance, conductor, what I am saying, this is conductor. Okay, this is almost constant, so this is a alloy, and here the resistivity decreases, so that means it must be a semiconductor. Okay, so from the option, now let's see the options. X is conductor or copper. Here copper is a conductor. Y is nichrome. Nichrome is an alloy of nickel, chromium and one more thing. Okay, X is copper, Y is nichrome and Z is semiconductor, or they should have given silicon or germanium. That would have been better. Okay, silicon or germanium are semiconductors. Okay, so copper, nichrome, silicon. Okay, so option C is correct. Yes, Dikshita, Sweet, Saida, most of you have corrected. Okay, in between I don't know, Kamareshwar Naik answered option A. I don't know which question. Given a current carrying wire of non-uniform cross section, let's finish this quickly. Given a current carrying wire of non-uniform cross section, which of the following constant through the length of the wire? Current and drift velocity, current only, current, electric field and drift speed, only drift speed. okay, given a current carrying wire of non-uniform cross section. So non-uniform cross section means obviously the cross section is different. Okay, so suppose this is area, this is B. So drift speed and area is a constant quantity. Okay, it is the equation of continuity. So drift speed into area is constant. So as area increases, drift speed decreases. As area decreases, drift speed increases. So only thing that remains constant is electric current. Okay, electric field also changes based on the area. Okay, electric field also can be strong, can be weak. So only thing that remains constant throughout the wire is current only. Only current. Yes, Vishnu Priya. Answer only once, Ayan Pasha. That helps me to identify. If you answer multiple times, Saida Fahim, for example, I missed because most of you have answered 3-4 times. Right? Sweet, Saida Fahim, even Saida Fahim also answered many times. Okay, answer only once. Now next question, the graph between variation of resistance of a metal wire as a function of its diameter, keeping the parameters like length and temperature constant is. So resistance and diameter. So resistance is given by rho L by A. So where is the diameter? It's flat line, but option is not given. So you have to dig more deeper because area is pi r square. Area of a circular or cylindrical wire is pi r square, right? Now obviously what is r? R is nothing but diameter by 2. So area is actually d square by 4. So we see that if you put it over here, it will be rho L pi d square upon 4. So, so resistance is inversely proportional to square of the diameter, and any inverse square diameter graph is this one. Inverse square graph is this one. Okay, so option 2 is correct. Okay, now this is one of the most famous pattern of KCET because out of 100 questions came based on graph. Okay, 90 questions have either this part or some of the other form of this graph. Okay, this graph is one of the most favorite graph in KCET exam, not in any other exam, only in KCET exam. Electric field E is the electric field inside a conductor whose material has conductivity sigma, resistivity rho. The current density inside the conductor is J, the correct form of Ohm's law. We know that J equals to sigma E. Now if you see, none of the option has given this as correct form. So if you change it a little bit, we will get electric field is J divided by sigma. Now 1 upon sigma is called rho. So it is rho J. So correct answer is resistivity into current density. Electric field is resistivity into current density. 1 by sigma is resistivity. Okay, sigma is conductivity. Conductivity and resistivity are reciprocal of each other. In the circuit shown, the end A is at potential V0 and end B is grounded. The current, electric current indicated in the circuit is. So any circuit which is drawn like this, remember this pattern. Okay, any circuit which is drawn like this represents, if you redraw this circuit, it will be our own favorite circuit, that is Wheatstone bridge. Okay, so suppose this is P, okay, this will be Q, this will be R, this will be S, and this is our galvanometer G. Okay, equivalent circuit. Okay, so this is the circuit of Wheatstone bridge. Any circuit drawn like this, you just need to redraw the circuit like this, then you will get this structure. Okay, so this is a Wheatstone bridge structure. Now in Wheatstone bridge, we know that if P by Q is equal to R by S, then there is no current that passes through the galvanometer, so galvanometer actually does not exist. So you can simply remove it, and if you remove it, then you see that this is in series, this is in series, and their combination is in parallel. Okay, so here also you see that this is R, this is R, this is R, this is R. So all the resistances are R. That means this is a Wheatstone bridge, and not only a Wheatstone bridge. Here this is actually does not exist. This portion actually does not exist. So basically what you can do, you can simply ignore this portion. Okay, this portion, this is the galvanometer, this is the galvanometer portion, so this does not conduct any current. Okay, any current does not conduct any current means what? You can simply delete it, right? So basically you delete it, so it does not have any effect over here. Similarly, if you see this portion also, this is also another Wheatstone bridge, 2R, 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 2R. That means this also does not, this is also a balanced Wheatstone bridge. So any balanced Wheatstone bridge, current through the galvanometer is 0. So galvanometer can be simply deleted. Okay, now if you find the equivalent resistance of this, it will be R plus R, that is 2R. Here also R plus R, 2R. Now 2R and 2R are in parallel, so equivalent resistance is 2R by 2. Okay, equal resistances in parallel. Don't put too much thought into it, just figure it out. R plus R, 2R, R plus R, 2R. Now 1 by R, 1 by 2R plus 1 by 2R will be 2 by 2R, that is equivalent is only R. So equivalent resistance of this portion is very simple, R. Similarly, because all of them are R, equivalent resistance is R. Here also all of the resistances are 2R, that means equivalent resistance will be simply 2R. Okay, again same method you can apply here. R plus R, 2R, 2R by 2 is R, 2R plus 2R is 4R, 4R, 4R in parallel, so 4R by 2 is 2R. Okay, so what is the total resistance? Total resistance is R plus 2R, that is 3R. So 3R is the total resistance. So now what is the current? They don't ask you the equivalent resistance, they don't ask you about resistance of individual charges. They ask you what is the current. So here the voltage is V0, here the voltage is 0. Grounded means 0. So what is current? Current is voltage difference. Current is voltage difference divided by total resistance. Okay, V by R. Okay, V by R. Now here, because one side is V0, another side is 0, you have to take the voltage difference. So it will be V0 by 3R as the current passing in the circuit. So it will be V0 by 3R. So Prajal, don't send so many emojis, it is very difficult. Sir, what happens if the grounded, it does not make a difference? Yes, grounded means it is 0. Potential is 0. Grounded means potential is 0. Nothing else. Okay, there is one question, I think in Comet K it came, this grounded one of the cell, electric cell in between, and they ask what is the potential difference. So that is an interesting question, not in KCET, but you remember that if something is grounded, potential is 0. Okay, it only thing that it affects is the potential. Grounded means electric potential is 0. Now here the question is, the electric current flowing through a given conductor varies with time. Actually in JEE there are a lot of critical questions that might be asked based on the grounded concept. In KCET not too many. Okay, they don't give a very difficult question except 1 or 2 every year. Okay, the electric current flowing through a given conductor varies with time as shown in the graph below. The number of the free electrons which flow through a given cross section of the conductor in the time interval 0 less than equals to t less than equal to 20 seconds is. So you have to find the electron which is flowing. So if you see that here current is given, Okay, I think let me use a separate color. So here current is given, here time is given, right? We know that current is actually charge divided by time. So charge equals to current into time, right? Now that means, because it's not a straight line graph, so it is a curved graph. So if you basically calculate the area under the graph, if you calculate the total area under this graph, you will get the total charge. Okay, so they do not ask you the total charge, they ask you the number of charge. So first we have to calculate the total charge, then Q is equal to NE or 6.25 into the charge to calculate the number of charge. First calculate the charge first. How to calculate the area of a trapezium? This is a trapezium. This kind of shape is called trapezium, this portion. This is called a trapezium. So how to calculate the area of a trapezium? Remember that area of a trapezium is, suppose this is A, this is B, this is the distance D. So area of a trapezium is half A plus B into D. Okay, these are the parallel sides. So sum of the parallel side into the distance between the parallel side. So we will use that formula over here. Okay, so this one having a side here, so this is 200, this is half of that, that means this must be 100. Okay, this is 5, this is 10, so this is 10, this distance is 10. Okay, this is 200, this is that is between 400 and 200, so this must be 300. Okay, this is 10, this distance is 10. So we will calculate the total area. Again, it's an easy question but slightly lengthy. So charge is given by, first this area is half into 100 plus 300 into the distance between them, which is 10, plus this is a rectangle side is 300 into 10. So this will be 300 into 10. Okay, so this will be half into 400 into 10. Okay, so it will be 200, and this here we will get 3000. So 3000 plus 2000, that is 5000. Now remember that here the current was given in milliammeter, so this will be millicoulomb or 5 coulomb. Okay, milli means 10 to the power of minus 3, so it will be 5 coulomb. Now you can directly calculate, so that's why I said many cases it will be very handy to calculate the number of charge, which can be calculated by 6.25 into 10 to the power of 18. This is for 1 coulomb of charge. How many coulomb are there? 5 coulomb is there, so multiply this with 5. Okay, so it will be 31.25 into 10 to the power of 18. But exact answer is not given. If you see, there is a decimal shifted here and 10 to the power value is increased by 1. So if you decimal shift 1 by 1 decimal, obviously you can write it 3.125, and then you have to increase the 10 to the power of value by 19. Okay, so correct answer is option A. So those who have randomly answered are wrong. Resha, Nisha, Rajani, Bhagya, Sweet Commander answered it correctly. Ayan Pasha also answered is correctly. Okay. Sir, do PYQs repeat without changing data? No, Rajani. I only 1 or 2 times exact same PYQs came. Okay, but that was like 10 years back. Okay. In last 10 years, no PYQ exactly repeated. But yes, concepts, formulas did repeat it, but exact PYQ without changing the formula does not repeat. But yes, these are the standards. These are the standard. For example, 6.25 into 10 to the power 18 is for 1 coulomb. Now, after solving this, suppose you found 4 coulomb charge. You just multiply by 4. Well, these are the standard values. So you have to remember those to solve questions quickly. the I versus V graph for a conductor at two different temperatures, 100 degrees and 400 degrees, is as shown in the figure. Okay, so this angle is 45. Let me change the color. So this angle is 45 and this is 30. Right now, the temperature coefficient of resistance of the conductor is about. So they ask you, they have given you graph and suddenly they are asking temperature coefficient. So remember that if V versus I graph is given, then resistance is 1 by slope. Resistance is 1 by slope of V versus I graph. V equals to IR, or I equals to V by R, or Y equals to 1 by R into X. Now here this 1 by R is the slope of the graph. So slope is 1 by R. So R is 1 by M. Right? Y equals to mx plus c is the equation of a straight line. So from there we calculated that the slope of the graph is actually, if you want to calculate the resistance, that will be 1 by slope. So what is the slope for 30 degrees? Slope for 30 degrees, for that is for point number 2. Right, this is 2, right, and this one I think 1. Anyway, just forget. So slope for 30 degrees. Slope for 30 degrees is given by tan 30. Tan 30 means 1 by root 3. Right? So resistance, correspondingly resistance for 30 degrees is root 3 ohm. Okay, what about that is 1.73 ohm. What about resistance for 45 degrees? Resistance for 45 degrees is 1, because tan theta is 1, so 1 by tan theta is also 1. Okay, so resistance for 45 degrees is easy. Now what is the temperature coefficient? To calculate temperature coefficient, what you need to do, you need to find the difference in resistance divided by difference in temperature. As easy as that. So 1.73 minus 1 divided by 400 minus 100, that is 0.73 by 300. Okay, so that will be 3 to the, so let me write it slightly differently, 73 by 3 into 10 to the power of minus 4. So 10 to the power of minus 4, 1020, 2 decimals are there, so 10 to the power of minus 4, 73 by 3. 73 means 3 to the 6, 3 to the 6 and 13, so it will be 3 fours are 12. So 14 into 10 to the power of minus 24 into 10 to the power of minus 4. Okay, so if you see that none of the answer is actually matching. None of the answer is actually matching with the calculation. Okay, so how to which one will be closest value? The closest value we can take is this. The closest value that you can take is this. So we will take this as our answer, even though the answer is actually not matching with any one of them. Okay, we can say this is 2.4 into 10 to the power of minus 4. Okay, so this is the closest value that you get, but from this given option only this is the closest answer, so we will take that as answer. Sir, can't we solve this question by temperature coefficient alpha at two different temperatures by formula? Yes, you can do that, but that will be taking longer, right? So you have to use RT equals to R naught 1 plus alpha T, and then RT2 equals to R naught 1 plus alpha T2. Okay, now divide them. So this is T1, T2. So T1 is root 3, T2 is 1. Okay, and then you will get 1 plus alpha into 100, this will be 1 plus alpha into 400. Okay, so this will take longer. Okay, and answer you will get the almost same. Only thing is that this is a shortcut way. The way I have solved is shortcut way. Okay, and your answer will be closest. Okay, there is I think one more formula where they use alpha equals to R1 into T2 plus R2 into T1 divided by R1 plus R2. I think there is one more formula. I am not sure. I need to check this. I forgot this. You can calculate after basically simplifying this. You get up with this formula. That is also okay. Okay, you can check that. RT2. There is a minus sign. R1 T2 minus R2 T1 divided by R2 minus R1. Okay, this is also another formula that you can use. Okay, so and you will get the same value as 3. Okay, you can check this. 1.73 into 400 minus 1 into 300 divided by 0.73. You can use this formula as well. Okay, sorry, extremely sorry, it is exactly opposite. R2 minus R1 by R1 T2 minus R2 T1. Yes, this formula you can use. Okay, if you use this formula, I think this will give you more accurate result. So 1.73 minus 1 divided by 1 into 400 minus 3 into 1.73. Okay, minus not 3, minus 100 into 1.73. So it will be 0.73 divided by 400 minus 173. So if you see that I have used almost the same formula, only I have used 400 minus 100. Okay, so that will give you more accurate formula, but the approximation method that I have used is simpler and easier. Okay, 300, 270, 227. So 227, 0.73 divided by 227, which will be closer to 0.7 by 200. Okay, which will be closer to 3.5 into 10 to the power of minus 3. Okay, which is again closer to 3 into 10 to the power of minus 3. So this is a shortcut, quick way to solve. This is more accurate, formula driven, exact way to solve. Okay, yes, Rajani. Okay, this way, this is the exact way. Yes, this formula I was talking about. Okay, from this derivation actually you can simplify and find this formula. Okay, now next question, last question of the day. Let's simplify. An electric bulb of 60 watt 120 volt is to be connected to 220 volt source. What resistance should be connected in series with the bulb so that the bulb glows properly? So we have 60 watt 120 volt. Okay, and the source is 220 volt source. Okay, so basically we have a bulb which glows at 120 volt. We have an external resistance R. Our supply is 220 volt. Okay, so that means we have to have a resistance which gets a drop of 100 volt across it. Okay, so resistance should get a 100 volt drop across it when the maximum current passes through the bulb. Now what is the maximum current that can a bulb withstand? We know that power is equals to V into I. Okay, V given is 120 volt, power is 60 watt, 120 volt is voltage. So current, maximum current that can allowed through the bulb is this, that is 0.5 ampere. So 0.5 ampere should pass, but only 120 volt should be across the bulb. That means remaining 220 minus 120, 220 minus 120, that is 100 volt should be dropped against this resistance. Okay, current is known, voltage is known. So what is the resistance? Resistance is V divided by current I. V, we know that it should be 100 volt from the conservation of energy or Kirchhoff's laws. Okay, so that means 200 ohm. So we require a 200 ohm resistance so that it can absorb the extra 100 volt source and the bulb glows properly. Okay, yes, not B, option C is correct. Option C is correct. Bhagya, Pooja, yes, correct answer is option C. Okay, so this is the end of today's lecture, and obviously the PDF will be available in our WhatsApp channel. Link is shared. It will be shared once more. If you want to get more updates about all the lectures and you want to download the PDF of this lecture and all the lectures that we are doing in 15-day challenge, don't forget to join our WhatsApp channel. Link of the WhatsApp channel is given in the description section, and obviously the request to all of you, please like this video, and if you are watching without subscribing, please don't forget to subscribe. Okay, subscriptions are important, likes are important. So close the chat now, almost the lecture is over, so close the chat and like this video now. Okay, so like this video and obviously subscribe those who have not subscribed to our channel. Okay, and you will be able to chat only once you have subscribed. So I will see you in a next lecture. Now next lecture will be I'm not sure, but it should be tomorrow morning 9 p.m. Okay, just let me confirm you once more. I will confirm you once more. It should be tomorrow morning. If not, I will let you know again. Okay, so make sure you check out on our WhatsApp channel if tomorrow morning I'm taking a lecture or not. Till then, bye, see you.